In question 6, we have a particle of mass m projected to slide up a plane. So it's going up in this direction. So there's forces acting back in this direction. We need to find out what they are. The plane is rough, so we have mu involved here. So show that the particle will travel a distance in number 1. We'll have to show that S is this. Okay, let's do another diagram here. We have, let's say the particle is here. We have mg coming down in this direction. We have our angle B in here and in here. We have normal reaction at this point. So we have a force going in this direction, and we have a force dragging it back down the plane as well, mu r. So this is going to be mg cos beta along here. This is going to be mg sine beta, opposite beta, right angle mg is the hypotenuse. So r is equal to mg cos beta. So the force back down the slope, mu r is going to be mu mg cos beta. So force is equal to ma. So my forces are mu mg cos beta plus mg sine beta. That's going to be equal to ma. So this gives me my acceleration. My acceleration is going to be mu g cos beta plus g sine beta. So we're looking for distance. S is equal to S. If we say that, I know it's projected up initially with u, but let's say that it starts from rest obviously, so V is equal to u. V squared is equal to u squared plus 2as is the information we need here. So my u squared for my V is equal to 2 times acceleration times s, so I'll just write 2as, so the s part will be equal to this u squared over twice the acceleration, so this guy by 2 mu g cos beta plus twice this guy 2g sine beta. And I think they want us to factor out the 2g here. So s is equal to u squared over 2g by mu cos beta plus sine beta, which is what they're looking for over here in part 1. Dimensional analysis is just the units. We haven't covered this yet, but distance is in meters. U squared is meters per second to be squared, and that's equal to m squared over s squared. Just square both. Acceleration down the bottom is, I'll put it over here, is meters per second squared. And if we have meters squared over s squared divided by m over s squared, we just get m with these 4 things. So my distance is an m and my answer is an m. So that's your dimensional analysis. We'll cover in more detail in 6th year. Show that there is a loss of energy. Okay, part 3, show the loss of energy is what they give there, mu squared by mu cos beta over twice sine beta plus u cos beta. So for the loss of energy, it starts off with potential energy and kinetic energy. mgh, h is 0 initially, and a half m by the speed, which was u, so u squared. So this is my initial. Then it goes to mgh, it travels a distance of s and then stops. So we got to get the height that it goes. This is s, b, this is the height. We can say that the sine of b is equal to h over s. So h has to be equal to the distance traveled by the sine of b. So mgh, because it stops to half mv squared, this is 0. So the loss of potential energy, or the loss of energy, is this half mu squared minus mgh. So we have a half mu squared minus mg by h, which is this guy. So let's just write s first, u squared over 2g by mu cos beta plus sine beta, or sine b. We have to multiply that by sine b on top. So what does this simplify to be? Well, we have some commonality. I can cancel my g's here first. And if we follow our rules of simplifying fractions, if we write this one as mu squared over 2, and cross multiply, we're going to get the 2 on the bottom by this side here, so 2 mu squared sine beta, 2 mu squared sine beta, and then we're multiplying this denominator here by the mu squared on top, so that's going to be, that in fact will be minus 2 mu squared sine beta. So then we're going to have 2 mu squared. Actually, I'll remove the bracket, so it's this 2 by the mu squared, and that's going to be by mu cos beta. Then we're going to have plus 2 mu squared by sine beta, and that's all going to be over the 2 on the bottom by this whole denominator here. So 4 times u cos beta plus sine beta. So these actually cancel. We have 2 mu squared sine beta and minus 2 mu squared sine beta. So if we divide top and bottom by 2, we're going to get mu squared mu cos b over 2 times mu cos b plus sine b. Is this what they were looking for? Mu squared mu cos beta, mu squared mu cos beta, and we have the same denominator. Okay, why does the principle of conservation of energy not apply in this case? Well, what other forces have we got acting on the system? We have mu, which is friction. So, and then if mu is 0.5 and beta is 45, mu is equal to 0.5, and the angle is equal to 45. What do they ask? What is the percentage loss of energy? Okay, so we just fill in our values here. U squared by 0.5 mu by the cos of 45 over twice 0.5 cos 45 plus sine 45. Typing this into a calculator, I'm just typing in 0.5 cos 45, and over the bottom it's giving me 1 over 6, so it's going to be mu squared over 6 is the loss. It started as a half mu squared over 2, so it's gone from mu squared over 2 to mu squared over 6. So we're going to have the loss is what it is now, mu squared over 6 divided by mu squared over 2. So I'm going to turn it upside down and multiply by 100. Looks like it's going to be 1 over 3 by 100, which is 33.33%. Quite an awkward question this, I think you'll agree. And then if mu is equal to 0, what's the loss of energy? If mu is equal to 0, and we're coming down to here. If we put 0 in here, suppose if mu is equal to 0, there's no loss because the energy is conserved. If mu is equal to 0. That completes question 6.